Hi everyone, welcome back to the channel. Today we are going to be looking at logarithms. So before we look at logarithms, let me just plug in my Teams chat once again. Y'all, please join the Teams chat if you need help with high school math. I provide free help there. Also subscribe, like the video, and comment any math topics you want to see. So going back to logs, the definition for logs is for all positive numbers a, where a cannot equal 1, and all positive numbers x, y is equal to log base a of x, means that x is equal to a to the power of y. So that's how you go from logarithm to exponential form. So let's take an example. Let's take 5 to the power of 4 equals 625. What you want to do is you want to do the curly method or the snail method, where you take the base, so 5, and you want to wrap around 625 and end at 4. So what that looks like is log base 5 of 625 is going to equal 4. So when you do the properties of logs, you know that log base 5 of 625 can be rewritten as log 625 divided by log 5. And if you put that into your calculator, it will give you 4. So that's how you can always check. Another example would be 1/2 raised to the power of -3 is equal to 8. So if we wrote that in log form, we would take the base 1/2, go towards the 8 and wrap around -3. As a logarithm, that's going to be log base 1/2 of 8 is going to equal -3. Again, you can rewrite that log as log 8 divided by log 1/2. If you plug that into your calculator, you will get -3. One last example, so 4 to the power of -2 is going to equal 116. Start with the 4, go towards the 116, and wrap around the -2. You're going to get log base 4 of 116 is going to equal -2. Again, if you want to check, just divide those and you will get -2. All right, so let's look at graphing logs. Say you have this graph. You're going to start by looking at a point. So take the point 9, 2. What you want to do is you want to plug that into the original equation and solve for a. So we're going to have 2 is going to equal log base a of 9. And now you want to try to figure that by rewriting that as an exponential. So you're going to have a squared equals 9. You're going to square root both sides, and you're going to get a equals 3. So your final equation should be y equals log base 3 of x. And that's how you figure out the equation for logs. Here, we'll do another example. So this time we're given a table, and then if you notice on the graph, one of the key points is not 1, 0. The point is actually shifted down 2 units from 1, 0. Instead of y equals log base a of x, you're going to have y equals log base a of x minus 2. So let's use a point. Let's use like 9, 0 to try to figure out what a is. And now we're going to have 0 is equal to log base a of 9 minus 2. Rewritten as an exponential, that's going to give us, if we add 2 to the other side, we're going to get 2 log base a of 9. Rewritten as an exponential, we get a squared equals 9, square root, we get a equals 3. So our final equation is log base 3 of x minus 2. And there you go.